Hi, everyone. Today's lesson starts our real-world applications of systems of linear equations. And before I get to the official flipped notes for tonight, I do plan on going back through the class examples we looked at. We did 2 together in class, just in case someone would like to hear it one more time. So if your notes from class are 100% good and you're comfortable, go ahead and feel free to fast forward the video to where you see that I start going through number 1 in the workshop packet. Otherwise, you can join me right here with where I start on the warm-up question. This document was passed out in class today. It says, after having tons of fun at the trampoline park for a friend's graduation party, you are trying to decide if you want to become a member. If you do not become a member, you must pay $15 per visit. If you become a member, they will charge you a yearly fee of $70, but only $5 per visit. Determine when being a member is cheaper than paying per visit. We discussed how our first job is to determine what kind of system this is. And to help us with that, everybody received this handout. Let me see if I can show you the full page. This handout is something we're going to reference throughout this entire activity of looking at real-world scenarios because it really helps us to figure out what we've got. We are either going to have a system with standard form as its structure or a system where slope-intercept form, y equals mx plus b, is the system. And the way we can figure that out is really to actually pay attention to the question we're being asked. So these are kind of like question starters, so to speak. So at the end of your real-world scenario, once you finish reading, ask yourself, what am I actually being asked? Once you know what you're being asked, we'll know which kind of system we've got. Notice for standard form, the list is a lot shorter. How many of each item, or find the price of each item. And here we have more options for slope-intercept form. How many until blank will be the same? When will you break even? Which is the better deal? Which would you choose? When will one be cheaper than the other? So let's go back and see what question we were asked here. It says, determine when being a member is cheaper than paying per visit. And if I look at that handout from class, and I look for a similarity in questions, that sounds a lot like this one. When will one be cheaper than the other? That is a y equals mx plus b system. And we're actually going to write that down right at the top. Y equals mx plus b system. That's going to guide what we look to write. So we'll keep this in mind. The directions say, define your variables and set up and solve the system. So let's define variables. Thinking back to Unit 2, we know that when we define variables, we do not have numbers here. We're describing what are the 2 measurable things that are happening. Because I know I'm dealing with y equals mx plus b, I know that m is a rate. And for a rate, I want to look for keywords like per, each, and every. So if I come back over here and I look for per, each, and every, is that something that you see here? Looking for per, each, or every? I see per visit. Did that stand out to you? I hope so. So because it's per visit, I know that x is going to be number of visits. And y here is always going to be some kind of total. So ask yourself, what's the big picture? What are we talking about here? Once I know how many times I'm going to this park, I'll know my total cost. So y is going to be total cost. Now that my variables are defined, I'm ready to set up my system. And again, mentally, I know I'm looking for 2 y equals mx plus b equations here. So the next step is to say, well, what's being compared? This whole thing is about belonging to a trampoline park. So we have information about being a member and information about being a non-member. What do we know about being a member? This is if you are not a member. Let me keep reading. Okay, here we go. If you become a member, they will charge you a yearly fee of $70, but only $5 per visit. $5 per visit, I know is my rate. Y equals 5x. $5 per visit. And then I have an initial cost, a yearly fee of $70. So my model for being a member is Y equals 5x plus 70. What do we know about not being a member? If you do not become a member, you must pay $15 per visit. So that is Y equals 15x. There is no initial cost. You just show up and you pay $15 every time you go. Y equals 15x. I now have my system, and we're right back to our skills that we practiced all last week. So ask yourself, I have a system where it says Y equals, Y equals. Will I be using substitution? Elimination? What do you think? Well, from last week, we reasoned out why it's a really good idea if one or more of my equations is solved for x or y, we will use substitution. So our steps for substitution are solve, first sub, and second sub. Both of these are solved for y, so it really doesn't matter which one we choose. I might think I'd just go with the first one. Maybe you go with the second, that's okay. But I put it here and I put it in a box. For first sub, we take the equation we did not use yet, which here is y equals 15x. And I ask myself, do I have something to substitute in for x or for y? Well, I come over here and I see that this says y equals. So I know I have something I can substitute in for y. So where I see y, I will be writing 5x plus 70, and then everything else will stay, equals 15x. But what's awesome is that now I just have an equation that's in terms of x. I do have variables on both sides of the line. Remember, you cannot combine like terms across this line. I cannot, let me repeat that, I cannot say 5x plus 15x is 20x. No, no, no. I do, however, want to get all of my x's on one side of the equal sign. And if I look, 15x is a term that has x, and it's kind of already by itself over here. So I think I will use math to move this positive 5x to the other side. And to do that, what is the opposite of a positive 5x? The opposite of a positive 5x is a negative 5x. So we will subtract 5x from both sides. That leaves 70 on the left side. 15x minus 5x is 10x. And I can now divide both sides by 10. I get x equals 7. I've got x, I need y. Over here I have this equation that says y equals 5x plus 70. Let's use it to find our y value. So where I see x, I will carefully use parentheses to substitute in 7. Plus 70 is still there. 5 times 7 is 35. Plus 70 equals 105. So as an ordered pair, let me be a little more clear. Y equals 105. As an ordered pair, the solution x comma y would be 7 comma 105. If this was last week, we would be done, right? We got our solution, we're done. But what's the new piece of what we're doing? What's the new learning? Well, the new learning is realizing that doing this systems work has a direct connection to the real world. So all of the math we just did, there is a connection to answering this question of determining when being a member is cheaper than paying per visit. This is where knowing how we defined our variables can really help. I know that x is 7. How do we define x right here? X is the number of visits. And then when I look at how we defined y is total cost. So this is the money. Also recall, where is this point? If I were to graph these two lines, this ordered pair is the solution. It's where the two lines intersect. If it's where they intersect, it's where they are the same. Each of these lines, though, represents something in the real world. One of these lines is being a member. One is being a non-member. And I just realized I should have drawn two increasing lines. Not that it's a big deal, but I want to fix it. So what does it mean that it's the same at that point? Well, there we go. So now I have two increasing lines. I'm a little more accurate. Okay. It's where they intersect, it's where they're equal. So it's where being a member and being a non-member is equal. So at 7 visits, it costs the same to be a member or a non-member. And in parentheses, we could put that equal cost. So if you go exactly 7 times to this place, it doesn't actually matter whether or not you chose to be a member or not. It would cost you the same. So then reason, we still need to answer the question, determine when being a member is cheaper than paying per visit. So at 7, you're the same. At 8 visits, or your 8th visit, it's cheaper to be a member. So go 7 times, you break even. Notice what I just said there, you break even. As of your 8th visit, you're saving money by being a member. And break even is actually what this was called in our notes last week when they're both solved for y equals mx plus b, y equals mx plus b. These are break even systems. This is one of our special cases from last week. And now we see the real world application. It's when the cost of being a member and being a non-member is even, breaks even. So less than 7, one is better. More than 7, the other is better. This is where they're the same. After doing this one in class, we started to look at our real world workshop, which will be used for the next 3 school days. And in class, I asked everyone to go ahead and read number 1 and decide what kind of system will this be. The Johnson family is determining whether they want to buy a summer pass to their local swimming pool. Without a summer pass, they must pay $12.50 per visit to the pool. If they buy the $50 summer pass, then they must pay $7.50 per visit to the pool. Help them determine when owning the summer pass is cheaper than paying per visit. Does that language sound familiar? When owning a summer pass is cheaper than paying per visit? Well, if we look at our handout, when will one be cheaper than the other? What kind of system do we know we'll be working with? Y equals mx plus b. And from this point forward, we will actually jot a little note down in the margin about what kind of system this is. So this will be a y equals mx plus b system. defining our variables, no numbers. How am I going to do that? Well, again, keywords. For the rate to know what X is, per, each, and every. We look for those vocab words. So if I look here, do you see per, each, or every? I see per visit. Did you see that? Per visit. So X equals number of visits. And again, big picture, what's the total we're talking about? We're talking about total cost. Again, total cost. Once you know how many times you go, then you'll know how much it'll cost you in total. We've defined our variables, so we are now ready to set up our system. Ask yourself, what's being compared? Here I see without a summer pass, I have information, and then with a summer pass. So in terms of our descriptors, we can write no pass, and then with pass. It will help us guide our equations here. So what's our model going to be without a pass? No pass. Well, without a summer pass, you pay $12.50 per visit. So y equals 1250x. How about with a pass? With a pass, if they buy, ooh, look, that pass costs $50. If they buy the $50 summer pass, then they must pay $7.50 per visit. So you pay $7.50 per visit, but you also have to buy that pass, which is $50 flat rate. We have our system. We're ready to solve. Now, I would like to point something out on the warm-up worksheet. In last week's notes, I mentioned that when we have a break-even system, where they're both solved for y equals y equals. So if these two are equal, then these are equal. And I mentioned that if you're comfortable with just jumping to setting the two equations equal, go ahead and do that. As of this first example, I do plan on, when I have a break-even system, straight up setting up this equality, setting one equal to the other. If you're comfortable with that, please join me in doing that. If you're not, go ahead and still work with your 3 steps. We'll still get the same answer. You'll just have a little bit of a pre-step right here, which is fine, totally okay. So to know when they're equal first, because I need to know when they're equal to know next how to figure out which is cheaper, we're going to set this one equal to this one. So that will look like 1250x equals 750x plus 50. Let's solve for x. To do that, we'll subtract 750x from both sides. I'll give you a second. Get your calculator. We're going to do 1250 minus 750. 1250 minus 750 is 5. So I have 5x equals, this is gone, 5x equals 50. Divide by 5, divide by 5, x equals 10. And we can add a label because I know x represents visits. So x equals 10 visits. So now I know when it's the same. So you want to make yourself a note. Same cost at 10 visits. But that wasn't the question. I mean, if that was the question, I'd be done. Make that either. That's my at symbol. Same cost. Is that a horrible at symbol? I think so. There we go. Same cost at 10 visits. So if the question said, well, when would it not matter which you choose, I would be done. You could say 10, because at 10 visits, the cost is the same to be with a pass or without a pass. But the question said, help them determine when owning the summer pass is cheaper than paying per visit. So if we followed the reasoning of the warm-up, we would reason that on the 11th visit, it's cheaper. But could we prove that? Yes, we can. How would we do that? We're going to plug it in. And this is something I want you to practice, so do it with me. We're going to set up neatly two pieces of work. First, we're going to say, how about no pass? How much would 11 visits cost if you don't have a pass? Well, my equation for not having a pass is y equals 1250x. So that would be y equals 1250, or let's use our function notation. F of 11. So f of 11 equals 1250 times 11. Go ahead and figure out what's 1250, 12.5 times 11. I get $137.50. So without a pass, that's how much it's going to cost me to go 11 times. How about if you have a pass? With pass. So we're still looking at 11 visits. Here's my equation for if I have a pass. So that's going to be 7.5 times 11 plus 50. Using your calculator, we should get 132.50. And if you could, please pause it. I genuinely want you to try 7.5 times 11 plus 50 and make sure you get the same answer as me. So now have we actually proven what we think is true? If you go 11 times without a pass, it's this much money. If you go with a pass, it's this much. Which one is less? This is less. So we have proven after 10 visits, it's cheaper or saves you money to have the pass. Number 2 was one that we did in class, but I chose to go in order, so I'm going to do this one again right now. This was part of our notes. So if anyone had questions on this, this is a good time to listen again, and we'll talk about it again. This one says, James and Rick walk by a local farmer's market and like what they see. James bought 5 apples and 10 oranges for $4, and Rick bought 3 apples and 9 oranges for $3. What is the cost of an apple and an orange? Our focus is going to be on this question. What is the cost? So go ahead and underline the question. What is the cost of an apple and an orange? Well, looking at my little worksheet over here, what question does that sound like? When I look, I'm thinking it sounds quite a bit like this. Find the price of each item. Is that what I'm being asked? Find the price of each item. This says, what is the cost of an apple and an orange? I think we're in good shape. What's the cost of each item? So because of that question, I know this is going to be an AX plus BY equals C system. And I want you to write that off to the side. It's going to guide us in how we set up our system. First step, as always, is to define variables. So X equals Y equals. Now, X and Y, it's not going to be the number of apples. I know how many apples that they bought, and I know how many oranges. So what are our variables going to be? A strategy is to actually look at the question being asked. Here, in AX plus BY systems, AX plus BY equals C, standard form systems, the question will always tell us what our variables are. It'll tell us our unknowns. The question asked, what is the cost of an apple and an orange? So X, the unknown for X is cost of an apple. And we'll set Y to represent cost of an orange. Now that I have my variables, we can write our system. Who are the two people being discussed here? Well, I see information about what James bought, and I see information about what Rick bought. So I know that I will have one equation about James and a second equation about Rick. Be conscious of how you use space. If you know that you write big, you might want to use a separate piece of paper, but if we start learning and practicing writing a little bit smaller and make sure we're neat, we should be able to fit everything we need to do. So what do we know about James? We know James bought 5 apples. 5. We don't know how much each of those apples cost, so 5x. And I know he also bought 10 oranges plus 10, but I don't know the cost. So 5x plus 10y equals his total amount spent. James bought 5 apples, 10 oranges, and he spent $4. So 5x plus 10y equals 4. That's one of our equations. Well, what do we know about Rick? It says Rick bought 3 apples, so 3 apples times whatever they cost, not sure about that yet, plus how many oranges? 9. 9 oranges times whatever those cost, also don't know that yet, equals he spent a total of $3. I now have a system that I can solve. Thinking back to our refresher days, would I be using substitution or elimination? My hope is that elimination comes to mind because these are both AX plus BY equals C. I do not have either of these solved for X or Y. So ask yourself, do you want your X's to cancel or Y's to cancel? Well, in class, the vote was to get the X's to cancel. To make that happen, we need to ask ourselves, what's the smallest value that both 3 and 5 divide into evenly? They're both factors of what smallest number? And the answer to that was 15. So that means that I want to work towards having a positive 15x and a negative 15x. Those would be my goal inverse values. To make that happen, well, I know 5 times 3 is 15. So if I multiply 3 by 3, I'll get my 15x. If this is a positive 15x, I need this to be a negative 15x. So I'm going to put this in parentheses, and I will multiply by what? Well, trying to get a negative 15, I know 3 times negative 5 would be a negative 15, so I multiply the whole equation by that. Let's see what we get for a new system. Distributing in 3, this becomes 15x plus 30y equals 12. And my second equation becomes negative 15x minus 45y equals negative 15. Watch your signs and also make sure that you distribute to all pieces. Otherwise, it will not come out correctly. Now that we have finished our multiplication here, let's see what happens when we linearly combine these. Well, 15x and a negative 15x, that cancels to 0, so that's gone, which is what my goal was, right? I wanted my x's to cancel. Let's see what's left over. 30y minus 45y is a negative 15y equals, and then I have 12 minus 15, that's negative 3. In class, we discussed how this, we're going to be working towards a decimal. And we should be good with that because in the real world, a lot of the real world is not perfect, nice whole numbers. So let's see what happens. We're going to divide both sides by negative 15. Go ahead and get your calculator out. we need to do -3 divided by -15. And if you want, you could kind of deal with the signs on your own. Know that a negative divided by a negative is a positive. So in your calculator, you could just work with 3 divided by 15. And we should get 0.2. We can then ask ourselves, well, what does this mean? If I look at how I defined my variables, y is the cost of an orange. So oranges cost how much money? What's 0.2 in money? 0.2 would be 20 cents each. So oranges cost 20 cents each. How are we going to go find how much the apples cost? Just like we did last week when we found one variable, we're going to go pull one of our original equations. Doesn't matter which. I think I'll try the top one. So 5x plus 10y equals 4. And we're going to take the value we just found, which is 0.2, and we'll substitute it in. So this will become 5x plus 10 times times 0.2 equals 4. This becomes 5x. What is 10 times 0.2? Go ahead and give that a shot. 10 times 0.2 is a positive 2 equals 4. And now we just need to use our algebra skills to solve. So I'll subtract 2 from both sides. That gets me 5x equals 4 minus 2 is 2. Dividing both sides by 5. I get x equals 0.4. And in class, again, we reasoned, what does 0.4 mean? Well, x, again, is defined as the cost of an apple. So apples cost $0.40 each. And I'm done. We also discussed in class, what does it mean for this to be a solution? Because I could write an ordered pair. Solution is 0.4 comma 0.2, x comma y, right? And if we were to graph this system, that ordered pair is where these two lines intersect. That's my solution. A store can't charge one cost for one person and one cost for the other. So the fact that this is where the two lines intersect, it's where what James paid for his groceries, for each of those products, in this case apples and oranges, where what James paid and what Rick paid is the same. And in a store, you would expect that the cost is the same regardless of who buys that item, which is why finding the solution to the system is finding a solution to this real-world question about what both of them paid for the apples and oranges. Very nice. So getting back to the flipped notes, and I hope that if you were able to jump because you didn't need the notes, you did so. I'm about to work on number 3. And by the way, if you are listening to it a second time to catch up on the notes or hear it again, I'm hoping that I was able to answer any questions you had left over from class. If not, let me know first thing tomorrow. We'll look at it some more. Taking a look at number 3. Number 3 says, write the linear system whose solution set is 6, 2. Express each equation in the system in slope-intercept form. So let's look at that a little closer. Write the linear system whose solution set is 6, 2. You can kind of ignore the word set. Look at this key vocab word here, solution. We just talked about what that means. What is a solution? It's where two lines are going to intersect. So when I look at my graph, let's find 6, 2. Starting at the origin, 1, 2, 3, 4, 5, 6, 2. There it is right there. So it says write the system. Let's write the system. What are these two lines? Let me highlight them for you. This one and this one. That point of intersection came from these two lines intersecting. Do I know the equations for these two lines? Yes, I do. 1, 2. It's given to me. That's nice. So my system is x plus 3y equals 12 is one of the equations. And then my other equation is x minus y equals 4. Are we done? Well, when I look, it says express each equation in the system in slope-intercept form. Prior knowledge, slope-intercept form is y equals mx plus b. Do we have y equals mx plus b here? No. So we have a little work to do, but this is fine. We've done this before. No worries. So I take x plus 3y equals 12, line down the equal sign. To get y equals mx plus b, we are going to solve for y. So coming over here, what needs to move? I have to solve for y. We can use subtraction to move x. So I'll subtract x from both sides. That gets me 3y equals negative x plus 12. And to finish this up, we'll divide by 3. So this is y equals, what does this become? Think back to these past couple days. It's a fraction. What fraction is it? Negative 1/3 x. And then 12 is divisible by 3. I get a positive 4. That was for which line? X plus 3y equals 12, right here? Let's see, does this make sense? B is 4, and my slope is down 1, right 3. Let's see. Y-intercept is 4, down 1, 1, 2, 3, down 1, 1, 2, 3. Check that out. How awesome. All right, let's work on the second one. X minus y equals 4. To solve for y, we'll subtract x from both sides. Negative y equals negative x plus 4. Am I done? No. We need to get rid of this negative. How is that going to happen? We are all expert solvers, so we know that there's an invisible negative 1 out front. We will divide by negative 1 everywhere. So my final answer here will be y equals x minus 4. Does this make sense? Let's see. Here's x minus y equals 4. So there's my y-intercept. B is negative 4 right there, negative 4. My slope, up 1, right 1, up 1, right 1. I am in good shape. We have successfully expressed each equation in slope-intercept form. A little side note, it didn't technically tell me that I needed to use algebra. So if you ever see a question like this again and it doesn't say show work algebraically, I would be cool if you just pull that from the graph. That's fine. But when in doubt, just show the work. And it's good practice for those of us who need help with solving. That being said, let's look at number 4. Number 4 says, write the linear system whose solution set is, check that out, this funky circle with a slash through it. Has anybody ever seen that before? It's called the empty set, because it's like a set, a circle with a line through it, empty set. Empty set. In other words, there is no point of intersection. Express each equation in the system in slope-intercept form. We can ask ourselves, if there's no point of intersection, what does that actually mean? No point of intersection means the lines do not intersect. And for lines to not intersect, it means they are parallel. Parallel lines. Let's go up and see if we can find parallel lines. I'm going to rewrite that. It's messy. Parallel lines. Let's go see. Do we have some parallel lines here? I see some. Do you see them? Let me get my highlighter out. Those are looking parallel to me. Here's one equation. Here's the other. X minus 3y equals negative 6, and x minus 3y equals 6. X minus 3y equals negative 6, and x minus 3y equals 6. The directions again say express each equation in the system in slope-intercept form. Solve for y. So x minus 3y equals negative 6, line down equal sign. I would ask that you pause and you actually try solving this one yourself. Get y equals mx plus b. So I'm going to subtract x from both sides. Negative 3y equals negative x minus 6. Divide everything by negative 3. Negative divided by negative is positive. So positive 1/3 x, negative 6 divided by negative 3, positive 2. There's one. Second one, x minus 3y equals positive 6, line down equal sign. Again, pause, you do it, and then I'll do it, and we'll compare. Subtracting x from both sides, we get negative 3y equals negative x plus 6. Divide everything by negative 3. Again, negative divided by negative is positive, so positive 1/3 x. Positive 6 divided by negative 3 is a negative 2. Are these parallel lines? Well, let's check. Let's look at the slopes. M is 1/3. M is 1/3. Same slope. How about these y-intercepts? Different y-intercepts. So these are parallel lines. They have the same slope, different y-intercepts. They will never intersect. Number 5. Jose interviewed for 2 different sales positions at competing companies. Bob's Discount Furniture has offered Jose a salary of $31,200 per year, plus 9% commission on the total sales he makes per week. Raymore and Flanagan will offer him $26,000 per year, plus a 15% commission on the total sales per week. Jose isn't sure which offer to accept. He's great at making a sale, but he's just not sure which job will be better in terms of his pay. Determine how much he needs to make in sales to earn the same salary at both places. What will his salary be? Which job should Jose take? Focus in on the question. It says determine, underline this with me. Determine how much he needs to make in sales to earn the same salary at both places. And once you've underlined the question, can you go look at the worksheet and tell me where does this fall on the worksheet? How much he needs to make to earn the same salary at both places. If I go look, do you see it? I see it. Until they will be the same. So I know that this is going to be a y equals mx plus b system. I'm going to write that down first, off to the side. We're comparing these two places, y equals mx plus b system. What are we comparing here? Well, before I can say that, we actually have to get some variables on the paper. So let's define variables first. X equals and y equals. Again, looking for keywords like per, each, and every. Per, each, and every. I see per week, the total sales he makes per week. total sales per week. So I know that X will be sales, which is money, per week. And the total is his total salary. Also in money. Now we're ready to say, what are we comparing? What two companies are we talking about? Well, we got Bob's, and we have Raymore and Flanagan. I'm just going to abbreviate it as Raymore. We're looking for y equals mx plus b. Remember, this is the framework we're thinking about right now. So I'm looking for y equals mx plus b for Bob's. When I look at Bob's Discount Furniture offered him a salary of $31,200 per year plus 9% commission on what he makes per week. So this is what he makes in the year. That's flat. That's a one-time salary for the year. So y equals $31,200 plus, how do you write 9% as a decimal? In your calculator, if you're not sure, do 9 divided by 100. You should get 0.09. So he makes 9% on whatever his sales per week are. How about for Raymore? Raymore and Flanagan is offering him $26,000 per year plus 15% on his total sales per week. How are we going to figure out when they're equal? Well, I have two y equals equations, and as we just discussed before, when that happens, we're going to just directly set these equivalent and solve. So we're going to solve neatly and write small. I'm even going to just shift this up a little bit. Set these equal and solve. That will look like 31,200 plus 0.09x equal to 26,000 plus 0.15x. And let's get our calculators out for sure. If we haven't yet, you know who you are. Go get your calculator because we are going to use them a lot to solve this question. I've got variables on both sides. Remember, ultimately our goal is something like x equals a number. So anything with an x, I want gathered to the left side. Anything that doesn't have x, I want it on the right. So what do we not want on this side? Well, this 31,200's got to go. It doesn't have a variable with it. So I'm going to subtract 31,200 from both sides. I get 0.09x equals, in your calculators, we need to do 26,000 minus 31,200. What did you get? I got negative 5,200. And then that plus 0.15 is still here. On this side, I only want numbers, so this 0.15x can't stay. I'm going to subtract that from both sides. .09x minus 0.15x is negative 0.06x. Go ahead and check that in your calculator, 0.09 minus 0.15. We should get negative 0.06x equals, that's gone. I bring down my negative 5,200. And last step, we're going to divide. Divide by negative 0.06, divide by negative 0.06. I know that negative divided by a negative is a positive, so I don't have to put that in a calculator. If you want to, you can, but you don't have to. For our final answer, What is 5,200 divided by 0.06? When I did that, I got x equals 86,667 dollars. What does this mean? What does this answer mean? Well, when I look at how I defined x, x is the sales he makes per week. So this means needs to sell 86,666, try that again, $86,667 in sales to make the same amount. At both places. So we just answered the first part. The first question said, determine how much he needs to make in sales to earn the same salary at both places. The answer to that was $86,667. So if he sells this much furniture, just realized we should take this off. Just sales, not sales per week. Okay, so if this is his sales, what will his actual salary be? Because this is what he's selling. That's not how much he's making. What will his salary be? Well, I know X, Y is his total salary. So let's go find it. How are we going to do that? Well, we're going to take one of our original. It doesn't matter which, right? Because at this much in sales, he makes the same at both places. So you choose. Doesn't matter which one. I think I'll probably just go with the top one just because. So I get Y equals 31,200 plus 0.09 times this, 86,667. So that's 31,200. In your calculators, let's do 0.09 times 86,667. What do you get? I get 7,800.03. Adding those two things together, 31,200 plus 7,800.03. All calculator work. Use your calculator. We should get 39,000.03. So salary will be $39,000.03. So we just answered this piece. What will his salary be? $39,003. $39,003. How about this follow-up question of which job should he take? Which job should Jose take? Explain. Well, maybe he reasons, I'm like a first-year associate. Man, I don't really think I can sell $86,667 worth of product in a year. I think on my first year, what do you think? How much could he possibly sell? Let's say he thinks 4,000? What if he says, I know I can sell $4,000 on average. Which job should I take? Well, let's plug it in. So let's compare. Bob's We're going to plug in 4,000. What if he makes 4,000? So if he makes 4,000 at Bob's, if he sells $4,000 worth of product at Bob's, y equals 31,200 plus 0.09 times 4,000. Using your calculator, that's 31,200 plus what? What's 0.09 times 4,000? I get 360. So at Bob's, he will make a salary of 31,560. What if he sells $4,000 worth of furniture at Raymore? Let's try. So Raymore would be this equation. So y equals 26,000 plus 0.15 times 4,000. How much does he make there? I'll bring down the 26,000. And then in my calculator, 0.15 times 4,600. So 26,000 plus 600 would mean he makes $26,600. So my personal opinion, I think if Jose thinks he's only going to make 4,000 in sales, look at the difference in salaries. If he makes this much, I say he should work at Bob's. So if he makes anything less than this, right? I just picked an arbitrary random number less than 86,000. So unless he thinks he's going to sell more than this, he should work at Bob's. He'll definitely make more money. So once you know your break-even X value, you choose something less or more and plug it in and make a judgment call. So a complete sentence would be, for me, if he sells less than, because I picked a number less than $86,000 worth of merchandise, he should definitely work at Bob's, and here's my math to back it up. One last one for the notes, number 6. Rodney's Kitchen Supplies makes and sells spoons and forks. It costs the store $2 to buy the supplies needed to make a fork, $1 for the supplies needed to make a spoon. The store sells the forks for $4 and the spoons for $5. Last month, Rodney's Kitchen Supplies spent $39 on supplies and sold all of the forks and spoons that were made last month using those supplies for $93. Whew, that's a mouthful. How many forks and spoons did they make? Okay, well, let's take a breath because that was a lot to read. Not in a bad way. We just have some good pieces of information to work our way through. A lot to take in. So if you want to pause for a second and reread it, go ahead. Even though I just read all of that, my immediate focus first is right here on the question. How many forks and spoons did they make? Based on that question, I can figure out what kind of system this will be. Which kind of system do you use for how many of each item? Go look at your worksheet. Which of these on the worksheet talks about how many of each item? I see it. Do you see it? I see it right here. How many of each? So right away I know I've got an AX plus BY equals C system. So coming back over here, I'm going to write that down. AX plus BY equals C system. It's going to guide my thinking for what we write. Let's define our variables. Remember, when I have an AX plus BY equals C system, the question actually helps me know what my variables are going to be. Check out the question. How many forks and spoons did they make? This is my unknown. The number of forks, number of spoons. So X will be number of forks, and we'll let Y be number of spoons. Now we're ready for our system. This one we're going to have to think a little bit about. Like our other AX plus BY equals C, I clearly had two people, right? What were their names? I forget. They bought fruit, the oranges and the apples. Their names were James and Rick. So I could clearly look for James and I could clearly look for Rick. Let's go back and read and see if we can figure out where our two equations are going to come from. It costs the store this much to buy supplies for forks and this for the spoon. And then the store sells the forks for this much and the spoons for this much. And then I know my totals. Last month, they spent $39, and then they sold all of their spoons and forks, and they made this much in profit. So this system, get your highlighters out, is comparing cost costs them $2 to buy what they need for a fork, $1 for the spoon, and what they sell. Their profit sells the forks for $4, spoons for $5. So I know that I will have one equation for cost and a second equation for profit. So let's put the cost one together first. Cost the store $2 for a fork. So $2, I don't know the number of forks. So 2x, because I don't know the number of forks. But I do know how much they cost. So $2 per fork. And then $1 for each spoon. So 1y. Whether or not you write that 1 is up to you. Now this is about cost. Do I know a total cost? What's in blue is for what they sell. That doesn't apply. Let's keep reading. Last month, Rodney's Kitchen, check that out. They spent a total of $39 for all of the supplies, right? Spent $39 on supplies. So my total cost, I set this equal to 39. I can't help it. I want to write this in blue. 2x plus y equals 39. Or 2x plus 1y equals 39. Okay, so I have my cost equation. How about profit? Let's go back and what was in our second color with what they sell. Store sells the forks. Forks is x. For $4, so 4x, they make $4 per fork plus, how about the spoons? They make $5 per spoon, so plus 5y. And do we have total profit? Keep reading. Anybody see it? Nope, that's the cost. So, check it out. Sold all of the forks and spoons that were made last month for $93. There's my total profit. So we're going to set this equal to 93. I have an AX plus BY system, so I know that I will use elimination. We will use elimination to solve this. Which variables should we try to get to be eliminated, x's or y's? Well, let's reason this out. There's 2x and 4x. To get an inverse here, I'd have to multiply both, right? Because the smallest number that 2 and 4 go into evenly is what? The smallest number 2 and 4 are both a factor of is 8. So I'd have to multiply both. But if you look at these y values, check this out. This is a 5y. This is a 1y. For 5y to cancel, this would have to be a negative 5. I can make that happen with just having to multiply one equation by negative 5. So I choose to get the y's to cancel. If you choose to go work with the x's, that's fine. We should get the same answer, but if I target the y values, I only have to multiply one equation. Let's see what we get. Negative 5 times 2x is negative 10x. Negative 5 times a positive y is a negative 5y equals 39 times negative 5. Go ahead and use your calculator. What's 39 times negative 5? I get negative 195. The profit equation, we didn't touch it, so that's going to stay 4x plus 5y equals 93. And now let's see what happens when we linearly combine these. My y's are gone. Those are inverses. That's 0. Negative 10x plus 4x is negative 6x equals negative 195 plus 93. What's that? Use your calculator. Negative 195 plus 93. I get negative 102. To finish solving for x, we will divide both sides by negative 6. X equals, I get 17. What does that mean? Well, look how you defined your variables. X equals number of forks, so they sold 17 forks. How do I find how many spoons they sold? Well, we're going to come back and use one of the original equations. I'm going to use the top one, 2x plus y equals 39. You could use the second one. We should get the same answer. So where I see x, I will plug in 17. So 2 times 17 plus y equals 39. 2 times 17, what's that? I got 34. Let me know if we agree. 34 plus y equals 39. Subtract 34 from both sides. What's 39 minus 34? I get y equals 5. Again, the meaning, here y equals number of spoons, so 5 spoons. So to answer this question, how many forks and how many spoons did they make? They made 17 forks and 5 spoons. And we're done. So your homework tonight is to use these notes to work on numbers 7 and 8. And we'll talk about those at the start of class tomorrow. Have a great day, everybody.